students, so I hope all of you are preparing really well for your PU2 chemistry examination, and I hope that you have already watched my PU2 complete organic chemistry revision video. I think it was uploaded in the morning. All of you would have watched it, revised all the reactions and all. So now we are going to revise all the name reactions quickly and also the mechanisms that can be asked in this particular exam. So chapter wise I'll give you mechanisms, and name reactions I have not given you chapter wise because we have to think from our brain like, okay, this reaction, where was it? I have to recall it, right? So you have to just sit with a notebook and a pen and just write down the name reactions that I'll be discussing. Okay, so I have tried to cover all the name reactions, but yes, if any of these reactions are left and if you find that I forgot anything, you can quickly comment down in the comment section and I will add it. Okay, so now coming to name reactions, but before that I want all of you to make something for this name reactions to revise it again and again easily. You make a column like this, okay, make a table like this where you write the name of the reaction, okay, you write the reactant, you write the reagent, and then you write the product. Okay, name of the reaction, reactant, reagent and product. Okay, so now coming to the first one, that is aldol condensation. So this is very simple. I have already highlighted the reagents, the reactants and the products in all the name reactions, so it won't be difficult for you. So aldol condensation, what happens is a condensation reaction in which a carbonyl moiety means it can be either aldehyde or a ketone, reacts to form a beta hydroxy aldehyde or beta hydroxy ketone. This is the first product formed in the presence of dilute NaOH. So you can see this is the reagent, this is the product and this is the reactant, and then this is followed by dehydration to give you conjugated enol, or you can here write down to give, I'll just change this one just a second, yes, to give alpha beta unsaturated aldehydes or ketones. Okay, reactions is already there. Here you can see what is missing here. I haven't given you the reactant, right, the reagent. So it is dilute NaOH. Can we guess this is from which chapter? Quickly comment down. This reaction is there in which chapter? This is there in aldehydes, ketones and carboxylic acids chapter, right? Okay. Now let's move to the second question, carbylamine reaction. So I'm trying to go alphabetical order so that when you recall, you can recall like this. Okay, A, aldol condensation, B, there was no reaction, C, carbylamine reaction is there. Okay, so yes, carbylamine reaction is the one in which synthesis of an isocyanide by the reaction of a primary amine, chloroform and base. So you have a primary amine, a chloroform and a base. It gives you isocyanide plus KCl plus H2. Byproducts we are not worried, right? So this is used as a test for, if you remember, this reaction is used as a test for primary amines, and this isocyanates produced a foul smell, right? I hope all of you can recall this reaction. Which chapter this one? This is from your chapter amines. Okay. Next, Cannizzaro reaction. Cannizzaro reaction again. Cannizzaro reaction is a chemical reaction that involves base-induced disproportionation reaction of two molecules of a non-enolizable aldehyde to yield a carboxylic acid and a primary alcohol. So here you cannot, if you don't find this word very difficult, if like it is difficult, you can use that involves a aldehyde or ketone without alpha hydrogen. Okay, so Cannizzaro reaction is a chemical reaction that involves the disproportionation reaction of two molecules of an aldehyde or ketone without an alpha hydrogen to yield a carboxylic acid and a primary alcohol. Okay, so here mechanism is given, don't have to write the mechanism, you can directly write down the product. So how can I'll just ignore this one. I will write, for example, if I take benzaldehyde, it is not visible also I think. So I will write, if I take benzaldehyde and if you take concentrated NaOH, okay, this one will get converted to COO minus Na plus, and this one will get converted to CH2OH. Okay, clear? Now we will go to, okay, next, can we guess this is from which reaction? Again, which chapter? It is the same, aldehydes, ketones and carboxylic acid. Okay, so this chapter has the maximum number of name reactions, so please make a note of all this. Next, coming to Clemmensen reduction. So Clemmensen reduction is a reaction that is used to reduce aldehydes or ketones to alkanes using hydrochloric acid and zinc amalgam. Very simple definition, simple reaction, right? This reaction is also from aldehydes, ketones and carboxylic acid. So from letter C, what all reactions we have got till now? We got Cannizzaro reaction, Clemmensen reduction and Carbylamine reaction, right? Next, we will move. Any other reactions do we have from letter C? I don't think so. So letter D also no reaction. E is there, Etard reaction. Okay, so Etard reaction is used for the preparation of benzaldehyde, right? So when you take toluene and react it with CrO2Cl2 in presence of CS2, you get this benzaldehyde. Okay, so Etard reaction is a chemical reaction that involves the direct oxidation of aromatic or heterocyclic, don't have to write this much, okay, direct oxidation of I'll just change this word for you, toluene. Just write down one word, that is toluene. Okay, so please write down with me. Etard reaction is a chemical reaction that involves the direct oxidation of toluene to an aldehyde using chromyl chloride, CrO2Cl2. Now this reaction is also from the chapter aldehydes, ketones and carboxylic acids. Okay, next, do we find any other reaction with E? I don't think so. F, yes, F we have Finkelstein reaction, our very favorite first chapter reactions, haloalkanes and haloarenes. Finkelstein reaction is used for the preparation of iodine, like iodoalkanes. Okay, I can say haloalkanes, iodoalkanes. So if you take any haloalkane and treat it with NaI in presence of dry acetone, you will get Ri, which is your iodoalkane, and this reaction is called as what? This reaction is called as your Finkelstein reaction. Okay, so this is from the chapter haloalkanes, right, and haloarenes. In this we have two name reactions majorly. Okay, so these are there. Next we will go to F over. Then G, do you find any reaction? Yes, we have Gattermann reaction, Gattermann-Koch reaction, Gabriel phthalimide synthesis, right? I can remember so many. Okay, with F also we have one more reaction, that is Friedel-Crafts alkylation. So we can also remember about Friedel-Crafts acylation, right? So here what happens? Here you take any CH3Cl in presence of a Lewis acid, FeCl3 or AlCl3, and you get R group attached to the ring. Okay, this is called as alkylation or Friedel-Crafts alkylation. Similarly, I can have here Friedel-Crafts acylation. So I will just write down here. You can take like this, CH3COCl in presence of AlCl3. That one will give you COCH3. Clear? Okay, next we have here Gabriel phthalimide reaction. In Gabriel phthalimide reaction, it is used for the synthesis of primary amines. So first we take a phthalimide, then you treat it with KOH. So this H is replaced with N minus and K plus. Then we take one RX, then we get NR. After that we treat it with NaOH to get CO minus, CO minus and RNH2. Okay, so Gabriel phthalimide synthesis is a chemical reaction that transfers primary alkyl halides into primary amines. Okay, or you can just write down primary alkyl halides into primary amines. Clear? Next, this is from the chapter amines. Oh, sorry, spelling mistake here, amines. Okay. Next we have Gattermann-Koch Gattermann reaction. So Gattermann reaction and Sandmeyer reaction are very, very similar. So you have to remember, in Gattermann reaction what happens? Benzene disonium chloride reacts with copper powder in presence of the corresponding halogen acid to give you what? Aromatic, to give you haloarenes, right? So for example, you have N2 plus and N2 plus and Cl minus CuHCl or CuHBr, you will get here chlorobenzene or bromobenzene. Okay, so this is from which chapter? Gattermann-Koch reaction. You have N2 plus, so this is also from your amines reaction, sorry, amines chapter. Next we have Gattermann-Koch reaction. Gattermann-Koch reaction, what happens? It is used for the preparation of benzaldehyde. You have to take a benzene ring, CO, HCl, AlCl3. This one will attack here and we will get benzaldehyde. So in Gattermann-Koch reaction, benzene is treated with carbon monoxide in the acidic medium in the presence of AlCl3 to give you benzaldehyde. Okay. So that will give you a reaction, and this one is also, as we are preparing here aldehydes, this is from aldehydes, ketones and carboxylic acid. Okay. Next we have 11th one. So after G, do we have any reaction on H? I think yes, we have Hoffmann bromamide degradation, but I think that reaction I have added later. I think, let me see, why is it not moving? Just a minute. Okay, some issue. Okay, so H, Hoffmann bromamide degradation I have left here, I have added it towards the end. Okay, then K, we have our Coles reaction, that is also there at the end. Okay, then L, M, N, O, P, Q, no, R, we have Reimer-Tiemann reaction. So Reimer-Tiemann reaction, you have to take a phenol, CHCl3 NaOH, you get benzaldehyde, okay, or we call it as salicylic aldehyde. So in the Reimer-Tiemann reaction, in the chemical reaction, that is used for the orthoformylation of phenols in the presence of CHCl3 and KOH. So you can just simply write down that phenols in Reimer-Tiemann reaction, phenols are reacted with CHCl3 and KOH to give you benzaldehyde. Always remember, you just have to make a sentence out of the reactants, reagents and the products. Okay, you don't have to frame this complicated sentences, not at all required. And then you have to write one example. Okay, so this is Reimer-Tiemann reaction, again is from your chapter, which one? Phenol, right? It is from alcohols, phenols and ethers. Okay, next we will move to, I don't know why there's an issue here, just a minute. Okay, okay, there's some issue here. Okay, next is your Rosenmund reaction. R, we have Rosenmund reaction. So in Rosenmund reaction, what happens? Acyl chlorides are converted to aldehydes in the presence of H2 palladium barium sulfate. So you have to simply write acyl chloride is hydrogenated to get aldehyde and in the presence of hydrogen, palladium and barium sulfate. Okay, so Rosenmund reaction is also from the aldehydes chapter, aldehydes, ketones and carboxylic acid. Okay, next we'll move to sand PQR. Then S is your Sandmeyer reaction. So Gattermann and Sandmeyer are very similar, so don't get confused. How I remember, I'll tell you. In Sandmeyer reaction, S is there. So we use the salt of copper. You use CuCl, CuBr we use. Okay, salt of copper. SS I have remembered like that. In Gattermann we use copper powder with HCl. Okay, so that is the difference here. Otherwise the reaction is same. You have to take N2 plus and Cl minus, that is benzene disonium chloride, and with that you have CuX and then you will get this one. Okay, next we will move to S, that is, I think we have Swarts reaction. Okay, yes, okay, before that we have Stefan reaction as well. So in Stefan reaction, what happens? Nitriles are converted to amines, right? So nitriles reacts with tin chloride and HCl to form iminium salt, which gives you aldehyde. Sorry, not amines, sorry, it is for aldehyde, Stefan reduction, right? Stefan reaction. So you have RCN with SnCl2 and HCl, we get this as an intermediate product, then finally we get RCHO. Okay, Stefan reaction. Next we have here, okay, I didn't mention the chapter, so this is also for the preparation of benzaldehyde. So it is also aldehydes, ketones and carboxylic acid. Next we will move to reaction 15th, that is your Swarts reaction. Again, Swarts reaction is used for the preparation of fluoroalkenes using primary, or you can say using your haloalkanes, using any metallic fluorides, you will get fluoroalkanes. Now this reaction is from the chapter haloalkanes, okay, haloarenes, haloalkanes and haloarenes. Okay, now we will move to 16th one. Okay, 16th one is your Williamson OVS, TUVWX, no reaction, Y no reaction, ZW we have Williamson ether synthesis. So this is from the names only, you know, it is used for the preparation of ethers. So here we have what? Here we have RX and RO minus. You have one alkoxide ion and one halide ion. This RO minus attacks on this R dash, we get ROR dash plus X, right? Now here the thing that you should keep in mind is this R dash X should be a primary alkyl halide, okay, otherwise the reaction will take place in the other way, or I can say the reaction, elimination reaction will dominate and you will get alkene as the major product. Okay, now we will move to next reaction, that is Wolff-Kishner reduction. So Wolff-Kishner reduction is for the reduction of aldehydes and ketones to hydrocarbons, right? Just like Clemmensen reduction, but Clemmensen reduction takes place in acidic medium, Wolff-Kishner reaction takes place in the basic medium. So we have NH2, NH2, KOH and alkali and heat. So what happens here, this O group is reduced to H2 group. Okay, next we have this one, okay, Wurtz reaction. So in Wurtz reaction what happens, we have RX Na, okay, then we get RR plus NaX, okay, Wurtz reaction, it is just for the preparation of alkanes. So if you use haloalkanes and sodium metal, you will get RR plus 2NaX, okay. Next we have, from Wurtz reaction only we have one more reaction, that is Wurtz-Fittig reaction. So in Wurtz-Fittig reaction, so I haven't add Fittig reaction during F letter because I want to discuss Fittig reaction here itself. So it is very easy to remember. If you remember Wurtz reaction, it is like Rx plus Na will give you RR, okay. Now if you have ARX plus Na, AR means a benzene ring or a cyclic ring, so you will get AR and AR. Now if you have R, so this is Wurtz reaction, this is Fittig reaction, okay, this is Wurtz reaction, this is Fittig reaction. Now if I mix these two, RX plus ARX, that will give me ARR, okay. So that is your Wurtz-Fittig reaction, clear? Okay, next we will see, why is it not okay? So I told you I have left some reaction during H, that is your HBZ reaction, and Hoffmann bromamide degradation also is there. So HBZ reaction is what you have whenever you have an alpha hydrogen, okay, in an carboxylic acid. If an alpha hydrogen is present, that alpha hydrogen is reacted with Br2 and phosphorus, okay. So generally you can write it in this form, so just write down like this, X2 and red phosphorus. So what will happen, this alpha hydrogen, okay, is replaced with X, whatever X you take, bromine, chlorine, whatever, it is replaced with Br group, okay. Next we have here, okay, one second, okay, next Hoffmann bromamide degradation reaction. So this is also starting from H. So here what happens, it is used to synthesize primary amines, but one carbon less here. So what you have to take, you have to take any amide, okay, and then if you treat it with bromine and aqueous KOH, okay, so aqueous bromine and NaOH or something like that, a base is there, then heat it, then what will happen, this part will evaporate or this part will not be there and you will get plain RNH2. So one carbon less amines we can get here, okay. Next we have here, okay, sorry, okay, next K1 I missed, I told you K Kolbe's reaction. So Kolbe's reaction is for the preparation of your salicylic acid. So you take here a phenol group, then you treat it with sodium hydroxide and carbon dioxide, you get O minus Na and COONA. After that H plus is given and you have OH and COOH group, Okay, so this is your Kolbe's reaction. So with this we have completed all the name reactions. So you can see only 22 reactions are there. Just make a table and revise, and if you think that I have missed any of these reactions that is there in the book, please comment down quickly. I will be incorporating it in my next videos. Okay, so that is your task now. Please, I think you have already watched my 70 out of 70 strategy video. There I have given each chapter important reactions, so just check if any of the reactions are left or not. Okay, I think it won't be there, but still a cross check we can do. I'll also check once again. You can also check and you can put in the comment section. Okay, now moving to the mechanisms. Chapter wise mechanism. First, haloalkanes and haloarenes, what mechanisms we have? SN1 and SN2. So SN1 is a two-step reaction. So basically what happens here, you have one alkyl halide. First step is the formation of a carbocation. So this bond breaks, a carbocation is formed here. The second step is the what? This is a slow step, so you must write down this slow and fast as well in the exam. In the slow step, in the second step, what happens? The OH minus or the nucleophile attacks here and we get a product. Now since a carbocation is formed here, nucleophile can attack from the opposite side, from the front side also, from the back side also. So a nucleophile can strike from any direction. As a result, the final product forms a racemic mixture here. Okay, now we have SN2 mechanism. In SN2 mechanism, what happens? We have a haloalkane, then we have a nucleophile. Now this nucleophile attacks on the carbon from the opposite side. So a transition state is formed in this reaction, right? So what is the difference between a stable carbocation and a transition state? Carbocation is a intermediate, it will stay some time in the reaction. Transition state is, it is a very short-lived period, intermediate. So immediately what happens? This bond will form and this bond will break, so you will get a compound like this. So you can see here OH will always be on the opposite side of Br. Okay, always. Next we'll go to alcohols, phenols and ethers. So here we have three important mechanisms. The first one is the conversion of alkenes to alcohols. Okay, alkenes to alcohols. So what happens? We have to add water in acidic medium, then you will get alkenes can be converted to alcohols. So here we have C double bond C. You just take water, protonated water here, it attacks on this one. So you can see that one side, this one is attacking on the H, so one side H is there, one side carbocation is formed. We got this one. Now what happens? The water molecule will re-attack on this carbon, okay, and we will get this one O plus H2. After this what happens? There is a deprotonation, then again water will absorb this H plus and you will get this one. Okay, clear? Okay, next we have here dehydration of alcohol. So alcohol's dehydration will give you alkenes. Okay, so first of all this one will get protonated O plus H2, then there will be removal of this protonated water and you will get carbocation, and then here we have this H, this one will form a double bond and we will get an alkene group. Clear? Okay, next we have here formation of ethers. So here you take an alcohol, in the presence of H plus, this first step it gets protonated, you get O plus H2. After that you take another molecule of the alcohol. Now see, this is O plus H2, so this carbon is highly electrophilic. This oxygen is having no lone pair, so it is highly nucleophilic, it can attack on this electrophilic carbon. This one will attack here, this bond will shift and we will get this one. So this is O plus H is formed here. Now there is deprotonation or H plus is removed and we will get this compound here. Okay, clear. Now we will move to aldehydes, ketones and carboxylic acid chapter. So here a general mechanism for nucleophilic addition is asked. So generally what happens, a nucleophile attacks on this carbon, then a bond like this, a tetrahedral structure is formed, O minus is formed and nucleophile is formed, then H plus attacks here and we get this structure. Right, now you have slow and step 1, here you have H plus fast and step 2. So that is what is formed here. Okay, next we have addition of HCN. So this is also a nucleophilic addition, but basically question is asked with respect to HCN addition. So first what happens, HCN in presence of a base gets converted to CN minus. This CN minus is the main nucleophile now. It can attack on this electropositive carbon, it attacks here, this O minus and tetrahedral intermediate is formed, then in the medium there is H plus and we get OH and CN, this is called cyanohydrine. Okay. Next we have amines chapter, Gabriel phthalimide synthesis. I have already discussed the mechanism in case of name reaction, so you can just see it once again. Okay, next we have, yes, so that's all. So I can say in other than this, no other mechanisms will be asked in the exam basically. Okay, but you have to check once the name reactions, if anything you find anywhere it is left, please comment down. And students, please remember this name reactions where it will be asked. You will have 2 marker one section, right? Haloalkanes, haloarenes and alcohols, phenols and ethers. So from there you can expect one name reaction, I think. And in the 5 marker question, basically it is 3 plus 2 marker questions, right? So in that 2 marker of all the questions, name reactions can be there, or some fill in the blanks or reactions based can be there. And 3 marker will mostly be mechanism, and if alcohols chapter, the 3 marker is definitely a mechanism. Out of these 3, any one will be asked, and then the 2 marker can be any name reaction or acidic order, anything like that. So organic chemistry, please do not fear, it is very, very predictable. Any doubts you have, please comment down, I will definitely address to it. And other than this, if you have any other problem, I have already given you my schedule, how will I be using these gap days for your preparation, what all videos will be coming. If you have any doubt, any other thing you want, that also you can comment down, we will definitely address it. Okay, I will have a live doubt clarification very soon. I think on 10th we can have a live doubt clarification where we can discuss all the doubts and everything. But if any other thing is also there, you can put down. So thank you for watching, and now students, please go and study, and you have to make a column of this, as I told you, a table of all these name reactions and revise them quickly. Okay, all the best.